Good morning to all of you. Welcome to the first Worldwide webinar. And that is actually good news because it's a series of 4 and there are more to follow. But first of all, I want to wish you a happy new year in good health and surrounded with all the people that you care about. I now give the floor to the Dean of the Worldwide Academy for an opening address, Mr. Omar Fritz Eriksson.
Hello and good morning all. Yeah, good morning, good afternoon, good evening. It's a great pleasure to see so many here. I see some 70 participants. Hello, good to see you all. First of all, I wish to wish you all a happy new year, hoping that you're all well as your families and loved ones. 2020 was a strange year, and I hope and I'm actually confident that 2021 will be better. And that we will return to some sort of normality, and that we will be able to be in the same room together anytime soon. It will take some time, but we will get there in the end. So I welcome you to this first webinar in a series of webinars arranged by the Worldwide Academy on topics of interest to IALA members and everyone involved in the provision of marine AtoN navigation services. These webinars are aimed at informing you on various topics which have been deemed interesting and important in this day and age. The Worldwide Academy, which is an integral part of the IALA Secretariat, seeks to do capacity building around the world and to educate the world on concepts and best practices for provision of marine AtoN navigation services. And I hope that you will find the content of this webinar informative, interesting, and I wish you all the best and urge you to keep your distance and stay safe. So over to you again, Geraldine.
Thank you, Omar. This series of technical webinars is developed to address some of the main challenges related to AtoN navigations worldwide. Each of these webinars will include a lecture on the topic. A case will be presented and you will have the opportunity to discuss or ask questions. The subject of today is AtoN Navigation Remote Monitoring, as this is an outcome of a former IALA webinar where Mr. Leewald from the United States Coast Guard explained how they benefit from remote monitoring to continue operations during pandemic restrictions. Mr. Leewald inspired me to choose this topic for a webinar. Actually, I am not an expert on this at all. The only expertise I have on remote monitoring is an unmanned engine room or security cameras at home. So I can now check if my son is using my car in the weekends. But today we have some very experienced experts with us, Mr. Simon Milliard and Mr. Mahdi Al-Moussawi. Before we start, I would like to inform that after the official webinar closes down, the line will stay open to chat. There will be a question and answer session at the end of each presentation, so please feel free to write your question in the chat box or to raise your hand at the end of the presentation. This webinar will be recorded and posted on the IALA YouTube channel. For now, to save some bandwidth, please switch off cameras and mute your microphones. The first presentation will be delivered by Mr. Simon Milliard, who started his career as a marine engineer cadet with the Royal Fleet Auxiliary Services. Interesting to see is that he fine-tuned his engineering and management skills in a brewery in London before he moved to Trinity House in 2008 as head of engineering and operations. Simon, the floor is yours.
Thank you, Geraldine, and welcome everybody, and thank you for the opportunity to deliver this lecture, which is one of the suite from the Level 1 AtoN Manager course. So I will now endeavour to take the screen, and if I can. So Geraldine, can you just confirm that you're seeing the lecture here?
Yes, I can see your presentation, Simon. Thank you.
Thank you. So as we said, this is the lecture from the Level 1 AtoN Manager course for from the Worldwide Academy. And the competencies to be gained are listed here with a satisfactory understanding of the various items around monitoring, the various technologies used, and monitoring regarding AIS. And the good reference point here is guideline 1008, which again expands on this topic. So if you want further deeper understanding, guideline 1008 is the one to follow. So we may ask ourselves, well, why monitor AtoN navigation? Here we have a beacon and a south cardinal mark. Various reasons why. We provide information to the AtoN service provider about the performance of their AtoN navigation. We can identify, we can verify reports from third parties. I'm sure we all have examples of a passing ship reports in saying an AtoN is not performing correctly, and yet when you go and visit, you find that it is. So it is a useful verification there. We can meet IALA availability standards, which would justify our operational performance standards. We should be able to reduce our total cost of ownership. But above all, and the most important thing, we minimize maritime accidents. So, and monitoring of AtoN navigation is an important part of that. So just a very quick recap. What are we trying to achieve here? For which monitoring will have the various categories of vital, important, and necessary availability that are set out in guideline 1035 from recommendation 130. And if you cannot consistently achieve above 95%, then the AtoN authority should really consider withdrawing that AtoN and replacing it with something that's more reliable. But the overriding issue here is to maximize availability and minimize your cost, because it's very easy to, well, it's not easy, but you can spend an awful lot of money maximizing availability, but we should be doing this just to cut down our costs. So which AtoN should be monitored? Well, actually, the choice is yours, and it's down to what the category of the AtoN navigation that you are looking at, and should be the outcome of a risk assessment. So many AtoN authorities will monitor their sort of category 1 AtoN navigation, and they may choose not to monitor their category 2 or 3, but equally they may monitor some. So it's down to you as the authority to decide what to do. And here's a list of the various items that AtoN that you could monitor. But again, it should come down from the competent authority following a risk assessment as to whether you monitor it or not. And then of course we move on to, well, how should you monitor it? There's a good guideline 1008 on this. Again, it will expand on this for you. And typically many developed competent authorities will monitor their major lighthouses and their major floating aids, and they may choose not to monitor their minor ones, or they may. And then that leads on to, well, which components to monitor on the AtoN navigation. But again, the choice is yours. However, the more you monitor, the more expensive it gets. And an important issue is that the more complex your monitoring system is, you risk spending lots of time and money responding to a failure in the monitoring system. So you will send out your ship, or you'll send out your technical staff to investigate a fault and find that it wasn't a fault after all, and it was a monitoring issue. So you need to be very aware that making it too complicated will come at a price, both on installation, and maintaining the monitoring system and responding to spurious reports. So again, here we have a list of what items that you can monitor, and technology enables you to monitor anything, but I would say be selective and monitor what, after your risk assessment, you consider to be important and that you really need to know, rather than what is just nice to know. But obviously you would start with, is the AtoN working? Then you would perhaps move on to your battery voltages. You may move then on to sort of current draw on the lantern, which will give you an indication of intensity. You may be able to monitor intensity if you have a developed system. Depending upon where your AtoN is, you may choose to monitor security to check it hasn't been, someone hasn't intruded in or vandalized it. And but again, the choice is yours. But I would urge you to be selective rather than go for a very comprehensive system, which can be a challenge to maintain. Now we come on to methods of remote monitoring, and there's a selection here. We come on to direct monitoring. So here, in the classic style, we can have user monitoring. This is where we sit back in the office and wait for the mariner to report in, usually through the local Coast Guard authority, and say, well, this AtoN is not working, the top mark is missing, the light isn't working. And that is, possibly quite a viable approach to some minor AtoN navigation, maybe a small Category 3 buoy or Category 2 buoy, perhaps. But it's no cost, but it's purely reactive, and you have no advance warning when things become unavailable, and you don't really know what your availability data is, because you don't know how long it was before somebody reported in. So it's cheap, but it's the lowest form of monitoring. But moving up a peg, we may have some paid observers. So these would typically be on a either volunteer or paid attendants or observers, whose job it would be to go out once, twice a day, check the AtoN's working, and report in. It's a little bit more proactive than user monitoring, because it's a regular event and will give you slightly better warning of items not working. And then you could have, in the classic form, full-time lighthouse keepers or attendants. Many authorities now have automated, and as technology has developed and enabled that. But on the other hand, lighthouse keepers, will provide a very high degree of performance for the AtoN. And not to be forgotten, they also provide employment and maintenance for the lighthouses and equipment whilst they're there. So that should not be dismissed, but it's probably quite expensive, and is falling out of favour and has gone in most areas. But some authorities do still retain lighthouse keepers. Now we move on to remote control monitoring systems. And here is where the technology creeps in. And in no particular order, we can have a SCADA system. That's an acronym for Supervisory Control and Data Acquisition. So this is where you have a screen back at the head office, and it draws in data from the various AtoN and informs you of the performance, or whether things are working or not. And again, from that, you can automatically draw down availability data. But it's expensive, and depending upon what style of system you go for, it's as expensive to buy, and it will be expensive to maintain, but you can get very good data from it. AIS is another form which you can use. We'll come on to that in a moment, but you can use that to monitor limited AtoN performance, and it's relatively cheap, relatively low cost, has slightly restricted range, to VHF range, but it's there and quite commonly used. Well, you can have what we refer to as the mobile interrogation monitoring. This is where your buoy tender or observers would monitor the AtoN status, and on a planned visit schedule. Another option is you can go for a proprietary monitoring system, which is sort of a SCADA-based system, and this is generally on offer for many AtoN providers. Will offer you a monitoring system to go with their AtoN. So when you buy their light, they will offer you a monitoring platform that is either free, it comes with a purchase, or you pay a relatively small subscription to access the SCADA screens online. And here it will either use satellite or 3G mobile phone or AIS as a transmission media. Generally, these ones will be managed by the AtoN provider, and they are very attractive because they offer a relatively low-cost form of monitoring the AtoNs that you have. But just a word of caution: be careful to select a supplier who is in it for the long term. It can be frustrating if you you've purchased into a very fine monitoring system, and you've put a lot of emotional energy into this, a lot of training into it, and then the supplier decides to not support that piece of equipment anymore, or the supplier is taken over and that piece of equipment, that piece of monitoring vanishes. So it's not easy, but just be careful, be aware that you're in the hands of a third-party supplier for the longer-term monitoring of your equipment. So a quick look at different systems that we have. We would have a remote terminal unit. This is a box of tricks on the AtoN that gathers data locally, and that transmits and sends it out from the AtoN to a central monitoring site. And some systems offer control. For example, AIS will only monitor, but if you have a SCADA system, then you can send a control signal to the AtoN. So, for example, you could turn a light off, or you could turn a standby light on, or you could start a generator if it hadn't started automatically, or getting down to the home comforts, you could turn the heating on the lighthouse before your staff arrive for maintenance. That probably is of no interest at all to Mardi, who's about to follow me from the Gulf, but it might be of interest to Jürgen there up in Denmark. So, yes, so we can look at status, condition normal. We can reset things. We can gather digital data, position, voltages, all the sort of things that will be of interest to the management of that AtoN. But a word of caution, I think it comes from Stephen, so thank you for that. Just because your systems are saying it's working doesn't necessarily prove Mariner can see it or use it. So, and there are many examples of this. Here's one of trees. In my experience, we had one which, according to the system, was working perfectly. But we had 3 reports of the light being reported as dim. So, and the attendant, it was a very bad, you know, the weather was very bad. It was raining and drizzly. The attendant went to the station and he didn't go in because of the access to it was a challenge, but he said, yes, the light's on. Another report came in, so that we sent the technicians, and we found that the lamp changer had only partially moved the light, had moved the lamp from one lamp to the next lamp. So the lamp that was working was not in focus in the center of the lens. So to somebody standing nearby, the light was working, but to the mariner 10 miles off, the light was not working. So just be cautious that the information you have, you know, is it actually telling the mariner the information it's meant to? Now, any remote monitoring system has these 3 components, which we've touched on. And there's a back end or a remote terminal unit on the AtoN navigation. And then we have a front end, which would be a screen to alert the authority of any issues. This could be automated, it could be manually monitored, and it has a means of transmitting the data from the AtoN to the alert system. That could be satellite, could be mobile phone, could be VHF, high frequency data link. Just a few considerations to bear in mind when you're looking at remote control. There's various AtoN systems, and we want sort of interoperability between them. So it's no good having a fantastic system that monitors your light if it can't then tell you your battery voltages, if that's what you wish to know. You've got to look at the range as to whether you are within VHF range or you have to rely on satellite. If you're looking at VHF, there could be obstructions. You may wish to consider redundancy, so that you have a backup monitoring system. And how cost effective is it? And again, this should all come out of a risk assessment of whether you should monitor and how comprehensive your monitoring system should be. So here's your options, which we touched on earlier. For us, you know, where I work at Trinity House, first port of call would be the local telephone line, if we can get a landline to the AtoN. So that would be a local a telephone line there. If that's not available, go for radio communication link, and we were using a VHF system from a supplier, but that is soon to be withdrawn. So we're going through a program of upgrading our communication links. But if there are systems available, VHF microwave can be very reliable. Or we can use telephone systems, you know, 3G, 5G, Internet of Things. If you can't get the range, then satellite is the way forward, but this can be very expensive. So you need to find a suitable satellite supplier, and also get a suitable package with them and make sure you understand what your communications costs will be before you get embedded with them, because it can be extremely expensive. But technology is developing, and there are some good packages available, and costs are coming down. So a quick touch on remote monitoring by AIS, and I think Mardi, to follow me, has some excellent experience on this in the Gulf region. So with MIGAS. It's all in recommendation A126, and so AIS AtoN, the message 21, the AtoN message. There is a selection of messages from AIS broadcasts, and it is sending out these this information on message 21. And obviously, to read this, you need a AIS receiver and the ability to interrogate the various messages. We're interested in 3 messages. The AtoN message, message 21, will give you this information. So it'll tell you if the AtoN is working, if it's in position, if it's a boy, and a few other things, whether it's real or virtual, and the type and name of the AtoN. But so this will tell you if a boy is out of position, as a bit of remote monitoring. But again, you need to alert yourself to that, and ideally have that done automatically. If you wish to do some monitoring with AIS, then you would need to turn to message 6, which it is the typical message where we would look at the status of the battery, whether the solar power is working. But you can monitor other things on there should you wish to do that. You could tell if the intruder alarm had any input you can give to it. And message 8 is generally reserved for met hydro data. But again, if you're retrieving message 6 or 8, you need a means to read them, which would generally be on a SCADA screen. But again, if you go back to A126, recommendation 126, you can see all the messages in there and what they're allocated for. So here's just a quick snapshot of a Trinity House buoy. It's a large navigation buoy. I think the focal height there is 7 meters from sea level to the light, to give you an idea of the size of it. And the picture on the right, and I'm hoping my screen here is my mouse there. The blue unit there, that's the remote terminal unit. So that's the unit that Trinity House have selected to gather the data through the various wiring connections, to gather the inputs and outputs that they've selected. This has been designed and built by the Trinity House engineers, and we had a particular problem with communications because the cost of the satellite communications was very high. So our first port of call would be on a floating buoy would be to get a mobile phone signal, 3G, but that wasn't always there, or it was flaky. You'd go and it was there one day and not very good the next. So this module here has both satellite and 3G comms provision. And first of all, when it is due to report in on change of status, light on or light off, it will hunt for a 3G signal. If it can find it, it will use it and send in the report. If it cannot find a 3G signal, I think it has three goes, then it will revert to a satellite, pick up the satellite signal and send in the report. So that's the current unit that we're sending out on our large navigation buoys. But key learning points from this lecture from the Academy here is AtoN should be monitored to identify failures. Not every AtoN, but your category 1s should really be the result of a risk assessment. If you've identified something as category 1, it's you really ought to be understanding what is happening to that AtoN 24 hours a day. And the only way to do that, in the absence of a lighthouse keeper, is to have an automatic monitoring system. You can use direct monitoring, but again, in the absence of keepers, it's not going to give you up-to-date information 24 hours a day about your category 1 AtoN. You've got to decide what components to monitor. By SCADA, it's expensive, or AIS, it's a lot cheaper. But again, that depends on your appetite and your risk assessment. Remote monitoring and control systems connect through a remote terminal unit to send their messages back. And there are many communications options, and they vary in cost and performance. And AIS, there you can use message 21 and message 6 can be used. So that concludes the little talk on monitoring and control. So I'll hand back to Geraldine, I think. Sure.
Thank you, Simon, for this excellent in-depth lecture on AtoN Remote Monitoring. I already learned a lot. For example, that it's important when you want to start with remote monitoring that you have to consider very well and be selective what you want to monitor, because otherwise it could end up in a very expensive action. There is now a moment for everybody to ask questions. You can raise them in the chat box by typing a message or by raising your hands. And I don't have an entire overview, but maybe my colleagues have an overview of people who want to ask a question to Simon. Thank you.
I identified the first participant who is posing a question, and that is Stephen Bennett.
Ah, Stephen.
Simon, can you hear me, my dear?
I can, Stephen, yes, thank you.
I've marked you out of 15. You scored 15.
Thank you.
That's no bullshit. My question, the Trinity House remote mobile slant satellite box, congratulations to Trinity House. Is that available commercially via delivery, do you know?
I don't believe it is. I think we're in the, I can't actually speak for Trinity House on this topic because I'm no longer engaged in the operations side. But I don't believe it is available commercially. People are welcome to put an inquiry in to Trinity House for that. But I think actually Trinity are busy rolling that out within their own program and have their work cut out doing that at the moment. So, but yes, it was developed by the Trinity House engineers. That is a very clever piece of kit from, from that side and ticked the boxes that we needed to get monitoring and to cut the cost of the satellite comms down.
Thank you very much.
Do we have any more questions to Simon? I don't see hands raised at the moment. You can also keep them to, I see a question in the chat box. If the presentation documents will be provided later, well, the whole webinar is being recorded as we speak. So it will be posted on YouTube. You will find the link on the IALA website later on. Do we have more questions? Let me see.
There's a hand.
Jacopo.
Yes, good morning. Good morning, everyone. Happy New Year.
Good morning.
Thank you.
Yes, I just have a question regarding the availability of the AtoN navigation. I don't know. I'm the pilot on the Kribi Deep Sea port, which is a new port in Cameroon. I just want to know what can we do between our capability to maintain the availability and the needs of the AtoN navigation. Do you have to, if I'm not sure, because if we cannot maintain the availability of 95%, but the need is there, how can we manage all this? It's very important to maintain the safety of navigation inside the area, and then the availability. If we see that we cannot maintain the availability, we cannot monitoring, how can we decide to replace the importance of the ATE and our capability to maintain the availability of 95%? I don't know if I'm clear.
I think that is a really good question and cuts to the nub of the challenges that competent authorities get. I think the rationale behind if you cannot achieve 95% is that when the mariner comes into that area, the mariner expects the ATO navigation to work. And so if it is declared as an ATO navigation, it should work. And 95% has been the figure. So if there are challenges that will not allow 95% to be achieved, it needs to be looked at. And well, what strategies can we put in place? We could look at the maintenance regime. You know, is it being maintained adequately? Or it could be that, well, if there are other features, for example, if it is being vandalized, or is it a weather item, then maybe we need to look at a different type of ATO navigation. And that is where maybe a virtual ATO navigation may be appropriate for, that would certainly work for the bigger vessels who would be able to interrogate that. But maybe put a different type of ATO navigation that will be more reliable. But generally speaking, if it is a conventional AtoN, you know, light or a Raycon, with a reasonable design and a good maintenance strategy, it should achieve the required category 1 or 2. So I would go and look at your design, installation, and maintenance. But again, if you can't do it, then withdraw it and think about maybe a simpler ATO navigation, and tell the mariner that no, it doesn't have a Raycon. It is a light, and then he won't be expecting to see that. They'll just be expecting to see the more basic form. But it's better to have a basic form that is there 99.8% of the time than a complicated one that's only there 90% of the time. Okay.
Okay.
Thank
Yes,
you.
I also have a second question regarding the monitoring the virtual AIS. I don't know.
If I may, sir, if I may, in terms of time, could we keep your question to the end of the webinar?
Okay.
Because we have other speakers as well, and many questions are coming in. We will try to answer them. Thank you very much, Simon, for answering these questions. I also want to point out to you, if your AtoN is not working, please remember to issue a navigational warning, because we see in many countries that this first step of issuing a navigational warning is often forgotten. So that is also important to consider. Please continue to write your questions in the chat box. You may also consider to put your email address after a question, because we may answer them afterwards, and if we don't have your contact details, that will be difficult. But I would now like to go to our next speaker, our next presenter, who will present a case. And this is Mr. Mahdi Al-Moussawi from Bahrain, who is the General Manager of the Middle East Navigation Aid Service. And he started as AtoN Navigation Offshore Operation Engineer on MENA's buoy tender vessels. But we all know him very well, as he was seconded to IALA as technical advisor for 2 years. Mahdi, the floor is yours. Thank you.
Thank you very much, Geraldine. Good morning or good day, everybody. Thank you. I would like to thank IALA for giving this opportunity, actually, to talk about our experience of the monitoring in general.
Par rapport au management de la diffusion des aides pour déclarer, pour identifier, on peut dire ça en anglais. How can we manage la diffusion des aides à la navigation?
Carry on, Mahdi.
Sorry, did you hear me? I don't know. I was.
Yes, we are hearing you. There was somebody that didn't shut up the microphone. So just carry on.
Yeah, I would like just to thank you, Geraldine, for the introduction, and I would like to thank IALA for giving this opportunity to show our experience on monitoring. I'm just asking, Omar, is my voice clear? Or?
It is very clear, and the pictures
You
are
can
beautiful.
Yeah. All right. Then. Thanks. So just for those who don't know MINOS, MINOS is MINOS is a Gulf operation division of London-based International Foundation of AtoN Navigation, and it is the only independent AtoN authority. We have 3 services, which is the AtoN, navigation warnings, and DGPS. We own 58 AtoNs in the Arabian Gulf, and majority of those buoys are located in the international routes, which are in 4 countries, 4 to 5 countries, and for attending those stations to rectify any failure, we either have to hire a vessel or to send engineers by plane to go there and then hire a boat to attend the buoys. So, and most of them are vital according, category 1, vital according to IALA standard. Therefore, there was a high necessity on having monitoring systems fitted on them. First of all, the first monitoring device technique we have used, as Simon mentioned earlier, was the Message 21. This was in 2008. On that time, this was the only way of and the only available monitoring system on that time. So what does Message 21, as Simon mentioned, monitors, said that this is an example for a buoy in Kingdom of Bahrain, where MINOS is based on. If you see, the red box contains the details that Message 21 provides, which is the ID, the name of the station, the type of the station, MSI number, the recent position, either it's on or off position, the status of the position, recent position, the coordinates, where is the buoy exactly on the time you see it, and the last scene, which is when was last seen. You either see it on the ECDIS or any other receivers, even on the small receivers on the boats, you would be able to see those information. So this information is not encrypted, but provided, and all mariners and stakeholders could see it. And this also helps for the enhancement of safety, where the ships could, see the buoy when they are passing it, electronically on their ECDIS devices. The issue, this was fine for us, the system, but not that good, where there was some weaknesses on that, where we couldn't, know the health of the buoy. Like if we had the AIS system in a different, if the light goes off, there won't be a possibility to know what is the status of it. And then, so we used to, put both circuits and do the power calculation and put both, the main light together with the AIS system. So once the battery fails or the AIS couldn't be seen, so we would know that the buoy is off. The other challenge was the VHF signal degradation during, especially winter times. If you can see in the first picture, this is during winter in the Gulf, and the other one is during summer, when there is, we notice that during high humidity, and if there is, low pressure, we will get good conductivity. You can see those blue dots are the buoys and the fixed structures fitted with AIS, where if you can see on the other picture on the left, that majority of them disappears during winter. So this was a challenging issue for us, as those buoys are located, majority of them are located out of ports, and the only way of report was that the users, I mean the vessels passing by them, this is the only way where we used to receive reports before we get the monitoring system on buoys. So there are some advantages of that message 6 or type 1, which all users could see it, as I mentioned, provides essential information for all mariners. The price was relevantly cheap. I mean, the units, and also it was an easy to program comparing with, message 6. Low running cost, as you can, there won't be any charges for transmitting those signals, except a small charge just from those TRAs on those, authorities on the governments. Like if you are intending to fit an AIS in any country, so you have to pay a small fees, I think, in some countries for the TRA for transmitting that, but it won't be that much. And you can monitor it via, AIS data providers like memberships and any website, including base stations actually, but you can monitor it. So there is no necessity of having a base station if there is any website or app providing a good coverage in your area. The disadvantage is that information is limited, as I mentioned earlier. VHF transmissivity because of degradation also requires several base stations to obtain good coverage. I mean, during the degradation, if you don't have enough base stations or the coverage of the websites are not that good, so you won't be able to see the station more often. Then on 2012, the AIS message 21 was the project started in 2008. Then we, with the communication, with attending IALA activities and committees, then we saw the authorities, the manufacturers, during those, one of the benefits of those meetings were that we found a manufacturer who started satellite monitoring systems. Then we designed, we worked on a project, a 3 to 4 years project with them to tell them what we need. Actually, we required a lot of information, a lot of inputs, because most of those stations were Cat 1 and fitted with Raycons and AIS and the main light. So we wanted to know each circuit, what is the performance of each. So for example, if you see the picture here, and also an accelerometer to know what is the status of the buoy, if any abnormal move happened. So if you can see in all pictures, there is a red boundary, which if there was any abnormal thing happens, the engineers will immediately receive an email, so they can check through the website from the provider to see what was the cause of the accident, or to know that what is the issue with it. So if you can see, this is an accelerometer. This is a AIS voltage to know the health of the battery of the AIS circuit. The main battery, this is for the main light, and also the Raycon. And the position. If you see this, the white, the gray square is the fence for the buoy, and those green dots are where the buoy was moving. So once the buoy goes out of this white box, means that it is out of its boundary and it is out of position, the engineers immediately receive an alarm, and this page on the position part, it will turn into red to say that it would be abnormal. There is other things and other benefits out of the monitoring that we noticed. We use them on trials. If you see in the picture below, we were trialing a chaining for AIS system to see the power consumption, and we noticed that the power consumption was so high and it used to go below 11 volt for the batteries. So we worked on continued working with the manufacturer to reach and to resolve the issue. The other picture on top left is a picture of one of the incidents happened, and incidents happened in one of the ports where the ship denied that they had the buoy. So with taking, going back to the system, and we found out on the same day with checking the accelerometer and the time, and also through the AIS base station we have, we matched the timing, the time they hit the buoy, and also the timing. So we provided the port with all information. And they used it for investigation, and they stopped the vessel, and they paid us back and the insurance paid for the repair of that buoy. And this is, the other picture on top right is for one of the lights where the manufacturer told us that, the battery sizing and solar sizing was sufficient for one characteristic, where we showed them that this was not sufficient and they should have changed the design, and they did it later on. They changed even their manuals for, the sizing. It was an ISO phase characteristic, which consumes a lot of power. And this is the satellite communication issue. The disadvantage of it, which I'm coming to other disadvantages, is that because of, maybe the satellite coverage on the area on a certain time may cause a disconnection between the buoy, the unit, the unit fitted on the buoy and the satellite, or the server, which is hosted by the product or the manufacturer location. And we faced that a few times. The advantages of that is that there is high input-output capabilities, as Simon mentioned before, that you can put more inputs, but the more inputs you put, the more expensive it would be. We can use more complicated, complex systems, like in sector lights and lighthouses. Like you can, put more. Sensors to sense other things that you want to know, like, for example, the motor on the lighthouse to see whether the lens is rotating properly, in big lighthouses. The advantage also is no base station required, as the manufacturer, they have the server where you can access through the app or the website to see the status of your buoy. And detailed information, as I showed before, that will be provided on that. We have the disadvantages of the satellite system is costly. The more inputs you put will be more cost on you, and also you have to pay a running fees for the satellite. The more time. The more call will be from the AtoN to satellite, the more cost it will be. But you will design that. You will need like 1 call, 2 call, or 3 call to know the status each day. And supplier hosts the server in terms of that if they had any technical issue in terms of control. So the host have the whole control. So it won't be you that would control that. And this was one of the challenges we had. Like the manufacturer changed the service provider, then we had to change the PCBs on those units because the satellite provider been changed. Then we, on 2014, we started the project with another company, which we saw the message 6 came into market, and we started trialing. And after 6 to 8 years, 8 months of trial, we succeed to get what we want. If you can see on this page that there is a lot of the same information that was on the web base is more detailed. So I won't go through them all. It's just you can see that, but I will explain the 3 on the right. This is the main battery voltage, and that's the current, charging current, and the last one is the Raycon voltage. Then we started as we find difficulties to see the AtoNs which are further, especially during winter. So we trialed. After we didn't succeed with the chaining, then we went into repeating the signal. So if you can see here, this buoy, which called Kaizen rig, this is a trial we did in Bahrain waters. These 3 stations are fitted with AIS, and those 2 stations are repeating the signal comes from Abu Salma and 5 Fathom patch. So we succeed to see the stations more often. How we would know that the signal received in the base station here is real or being repeated? If you can see on the screen, if it's 0, then it's a real and direct signal, and if it's 1, means that being repeated from the stations in the middle. And also we did another, this was a trial, then later on we have fixed the unit also, the message 6, type 3 have the capability of sending a virtual signal, which this buoy in the middle fitted with real AIS, and the other buoys, the 4 stations, the 2 on the top and the 2 and below are virtual, are not real. So the advantages are that all users could see it. I mean, they can see the message 21 actually, because message 6 contains the 21 as well. Provide the essential information, as I mentioned, through the message 6, but the owner of the system can see it, which is an advantage, and others cannot see it through your base stations. So the information, the buoy health, the station health will be encrypted. It is also easy to program, as the softwares nowadays are more user-friendly, low operation cost, as in terms of like you don't have to pay for the signal, only maybe a small amount for each unit, for the TRA and any authority. Service providers own the system. You will own the system. You have your own base stations where you can see those stations. Capability of sending virtual AtoN, as I showed in the last picture, repeating data from other AtoNs. AtoN performance analysis, which is like you can collect the data, then to do, to check the station's availability, which we are doing actually. And the entire system is owned and controlled by the service provider. And also the disadvantages are the establishment cost is high actually, because you need the units and also the base stations, where if you don't own some shore stations, if you are not an authority, so you have to pay, and there is a lot of fees for other things like to get the TRA approvals and things like that. Again, you have VHF transmissivity. By repeating, you will reduce it, but it won't be 100% perfect. There will be degradation. It will affect it. You won't be able to see it. It depends upon the size of the area that you are covering or where your buoys are located. Like if they are in the port itself, so it won't be an issue, I think. It depends on the distance. I mean, if it's more than 12 miles, from my experience, it would be, if it's within 12 miles, it would be fine. So the advantages of monitoring in short is that reduce the downtime, that you can attend the station before it fails. I will show you an example later on that happened during COVID-19. Verified AtoN system is operational, where you are sitting in your office, you can know whether it's operational or not. Reduce incidents of faults, as I showed in the example above, that we resized the power system again, and you can figure out what is the issue and troubleshoot it. Assist on investigation, as the case been shown earlier in one of the ports. Assisting and scheduling maintenance visits to minimize main time between failure. This is a graph of how we achieved. How the main time between failures been reduced in Minos. This is from our experience. If you see in 2011, we had 96 failures. Then it was reducing to 88, and till 2019 we only 30 failures at the end of the year. This was all because we have rectified and figured out what was the issue. So we have rescheduled some of the maintenance schedules, like, or we did resizing and so on. Last thing is the monitoring during COVID-19. This is one of the examples that we had an issue in one of the buoys. The AIS battery voltage, where we noticed that the voltage is dropping, but it was within the operational boundary, which was 12 volt, but it was too close to 10 volt. On that time, the travel were stopped during that time, and we have a plan, and we informed the relevant port that this buoy AIS battery is draining, but we are planning to attend the buoy once the flights open. Then in September, we were able to attend the station, and the engineers went and changed the battery, and if you can see that everything went back to normal. This was my presentation. Thank you very much. And this is my contact details if you had any question later on.
Thank you very much, Mahdi, for this wonderful presentation, who shows good practices. And I'm very happy you pointed out each time the pros and cons of each system, which will be extremely helpful to organizations considering remote monitoring. I now want to open the floor for questions, especially to Mahdi concerning this presentation. I don't see them in the chat box, but maybe somebody is raising his hand, so please ask your questions specifically on Mahdi. Do we have any question? I don't see any hands raising. Of course, many of these questions can be answered with our courses that we develop and deliver with various training organizations around the world and online. And I would now quickly want to give the floor to my colleague, Kevin Gregory, who will show you what we have on upcoming courses for this year. Please, Kevin, are you available?
Yes, Geraldine, thank you very much. I'll just share my screen.
Thank you, Kevin.
Okay, well, good morning, good afternoon and good evening, everybody. And thank you to Simon and Maddie for those excellent presentations. Lots of excellent quality information there, and it's quite possible that you'll want to know more, particularly following Simon's very informative lecture, and then Maddie showing how we can bring these techniques and technologies to life. So within the Academy, we run and administer several different training programs related to a range of topics. Today, I'm just going to brief you a little bit on the aids to navigation management topics, as that is been the subject of the webinar today and will be into the future. So apart from technical knowledge in our training programs, you'll always meet a whole host of other professionals and create long networks of colleagues and friends that you can work with long into the future to share your aids to navigation challenges. And here's a group of students from the ASEAN region who trained with us a couple of years ago. But you also go away with a lot of technical knowledge. And here's just one student set of notes from our level 1 aids to navigation manager course. And this student from the People's Republic of China now has a mass of technical information, a mass of personal and professional contacts, and their own aids to navigation manual written by them for them. So within the aids to navigation management suite of training, we have 3 courses available, and the information today has been drawn predominantly from the level 1.1 aids to navigation manager course. This is one of our most popular courses, which covers all aspects of marine aids to navigation management. We also have the course on the Master of Marine Aids to Navigation Management, which is more of a strategic look at aids to navigation provision, and the use of the IALA risk management toolbox is the 3rd course, which really focuses on the SOLAS obligations for assessing the volume of traffic and the degree of risk. And you can see from the chart there, we have now a worldwide spread of alumni that we work with, and the demand for the qualifications is steadily growing, and the qualifications now are truly global to meet IALA's goals of harmonisation and standardisation of aids to navigation provision. So the aids to navigation manager course covers several different topics. You get a comprehensive input on the international standards related to AtoN provision, as well as nautical knowledge. So that's what we need to provide, why we need to provide it, and importantly, how the mariners are going to use what we're going to provide, because they're our main stakeholder group. We're providing the AtoN for the mariners, so it's important to know their needs. The lecture that we had today comes from the technical aspects of aids to navigation management. So that's more of the technical engineering of aids to navigation. And we round off with a very practical risk-based aids to navigation implementation and management study based on a real-life scenario. So that's more of a hands-on aids to navigation planning task, as you can see in the pictures here on the right-hand side. So I'll keep this brief because I know there are some questions there for Maddie. I saw a couple of hands go up before I took the floor here, so I'll turn back over to the topic at hand. But if you'd like to know more, you can see on our website in the Academy section, we deliver the training through distance learning at the moment, which may be convenient with the current restrictions, but also through a whole range of accredited training organisations around the world. Simon at Trinity House leads an accredited training organisation, and very soon Maddie's organisation in the Middle East will be starting training as soon as this COVID situation permits. But we have a whole range of information available. You get good quality resources, including this new suite of textbooks, which covers all aspects of aids to navigation management. Are a fantastic learning resource for you to keep and use, all with a view to implementing effectively the IALA standards to ensure you comply with the SOLAS Convention. So I think there are going to be plenty of questions for Maddie and Simon. So I'll pull back there, but do get in touch if you would like more information on our training, and would be delighted to welcome you on courses which start throughout the year. So there's never long to wait if you are interested. Thanks very much.
Thank you, Kevin. Thank you very much for informing us on our course program. Omar, do you want to have the floor before you leave, or do you want to point out a few questions? Because I saw questions typically on the limits of aids to navigation remote monitoring, and there are some limits, I believe.
Yeah, I tried to keep track of some of the questions that came, and I'll mix them. They're both for Simon and Maddie. Mm-hmm. The first question from Andis. Could you please describe, this is for Simon, I think, could you please describe with few sentences the role of VDES and ASM, application specific messages, to AtoN and its remote monitoring services, or remote monitoring of AtoN? Simon, do you have an answer to that? I guess not.
Do we have another expert in the room?
There might be another expert in the room. Ernie Betty, I noted that you are here. Would you like to take the floor and tell us, is it possible to use VDES and what is the role of the application-specific messages in AtoN monitoring?
I can give you a short brief, as we know at the moment. The VDES does include AIS, and the ASM component is being certified at the moment through Working Group TC80, so it will have a role, and there are some messages being developed for it, but none of those have been published as yet, and therefore, as we stand today, it can be used for remote monitoring as a data channel, but not as a channel between the AtoN and the vessel.
Okay, thank you very much, and stay close by, because there's another question actually. Considering this is from Pablo Racionero, considering a big channel marked with floating buoys, are there any limitations on the number of buoys monitored by AIS? Basically, this is about the capacity of the AIS channel or channels. Ernie.
The AtoN is just viewed as another message on the channel, and therefore the AIS channel is limited, obviously, by the number of messages it can handle. But this is way below, this is way in excess of any AtoN that would be able to be used. The challenges in using the amount of AtoNs that can be used on an AIS channel are the slots that are reserved for the AtoN. How many of those slots are reserved, how many of those slots are used, and how those AtoNs are scheduled inside the slots that are reserved on the channel. And if there is a slot reservation process in place within the AIS AtoN environment.
Okay, thank you. Simon, you raised your hand.
Yeah, Yes, if I could just chip into that response, please, and thank you, Ernie, for your technical answers there, which I was grateful for. Thank you. I think if we're considering overloading the sort of VHF data link on that number of AIS AtoN targets, then we're really going to fog the screen for the mariner. And the AIS may be doing its job, but the ECDIS screen on the ship will be overloaded, and the mariner cannot then see. He won't be able to see the channel for all the AIS targets. So I think, in my mind, the limitation may not be the AIS capacity. It will be more the ability for the mariner to interpret, because there will be too many targets around. So I would urge caution on having too many AIS targets in one area. Thank you.
Okay. Another question for you, Simon, is what proportion of AtoN navigation are normally monitored by an authority through remote monitoring systems? And is this likely to change in the future?
I can't speak for other authorities, but for Trinity House, typically we monitor all our lighthouses, and we have on the number of floating AtoN, we have in the region of 450 floating AtoN, of which we monitor about 60. So if that gives you an indication, but that is entirely down to a risk assessment of the categorization and importance of each AtoN, and that will vary depending upon your geography and the waters and the volume of traffic and the degree of risk. So that is not a benchmark to be used. That's just where we have arrived at.
Okay, thank you. Let me see. Marty, you raised your hand. Perhaps you want to provide more.
Yeah, just something to add on what Simon said about the AIS is that we have noticed that type 3 could be seen and not affected much when there is a lot of AIS traffic. So type 3 is much better than type 1, especially when there is a lot of vessels around with the class A AIS. So.
Okay, thank you for that. Abdullah, I have seen your hand. Just wait a moment. There was Yakubu. You had a second question there, which you were asked to save until the end here. Would you like to come back, Yakubu Saliu?
Yes, thank you. Thank you very much. I just want to know about what is the advantage of the virtual AIS, because I think that the advantage of having a virtual or not a normal AIS, the virtual AIS, to monitoring the position of maybe the buoy system or the virtual AIS.
Virtual AIS, yeah. Okay.
The aid of navigation, the position.
Simon, did you catch the question?
No, I didn't. I'm sorry, I missed that.
Okay, I think you're talking about virtual AIS, right?
Yeah, the advantage and disadvantage to using the virtual AIS.
Okay. Yeah, I mean, virtual is a fantastic provision, but I think you have to remember that many mariners will not necessarily see it because they're not looking for it, and we have had trials where a virtual AtoN was put in was put on a shipping lane, and it was just completely ignored because not everybody is attuned to looking at it. But I think in time people will get more used to using a virtual AIS AtoN, and if it is publicized as being virtual, then the bigger ships certainly should use that. Another disadvantage is that the range of the virtual is not from the virtual AtoN position, it's from the transmitting aerial. So if the virtual AtoN is, say, 10 nautical miles away from the transmitting station, a vessel may only see that for, you know, a limited range away from that. So I think that is another disadvantage. But yeah, I think the virtual has yet to become fully accepted by all the mariners. And some I think in China they have a very clever system where on a channel, the center of the channel is reserved for large ships and is marked virtually. And so all the large ships have the ability to read it, and they are expecting to read it. And the smaller vessels with the shallower draft are guided to the edges of the channels where the bigger ships cannot go. So that's an intelligent use of virtual. Also, after the hurricane season in America, we heard from, I think it was Dave Leewald and colleagues, that they were using virtual for immediate reinstallation after the hurricane took out many of the physical AtoN. So they used that as a temporary measure whilst they got their physical AtoN back online.
Excellent. Thank you for that. And now, Abdullah Rafiq, you had a question?
Good afternoon to all. I'm Abdullah Rafiq. Can you hear me, sir?
Yes, we can hear you. Yes.
I've got questions for Mahdi. All the three systems here discussed, may I know the ranges of the operation of all three systems?
Yeah, this is about the range of the different types of monitoring system, operational range. Yes. So Mahdi, do you have a reply for that?
Yeah, it depends on the mean of each system we have. For example, the best one is the satellite monitoring system, where it depends on the coverage of the satellite. So if you are using one of the well-known satellite providers, so you would get a good coverage. Where on the AIS, you are confined, and depends on number of base stations you have, or yeah.
Yeah.
Yeah, thank you very much, sir. So one more question related to it. In the third system in AIS transponder type 3 in message 21 and 6, if my stretch is around 250 nautical miles and all the total stretch is covered by AIS, so can I integrate my other AtoNs into that messaging system, Mr. Mahdi?
Sorry, Abdullah, I didn't hear you properly because your mic says. Omar, have you heard?
I didn't quite catch the question. Abdullah, try once again. Abdullah, if you could repeat your question again.
Okay, sir. So if my range of monitoring or the stretch of monitoring is 250 nautical miles, and that complete stretch is covered with AIS and other AtoNs also, so can I integrate other AtoNs in the AIS transponder type 3 message 21 and 6? Is it possible, sir?
I'm not quite catching your question. I'm sorry, but if you would, yeah, please write it in the chat, and we can take it later. I'm conscious of the time now, but I'll take one more. George, Kevin, Igor, you have a question, sir?
Yes, thank you. How we have to do for the maintenance so that the system monitoring cannot fail?
It's difficult to hear you.
Vous êtes francophone, monsieur? Vous êtes francophone?
Do you speak French? Parlez-vous français?
Oh, yeah, I speak French. I speak French very, very well.
Okay, you can also try in French.
Je voulais dire comment allons-nous faire pour la maintenance? Yes.
It was interrupted now.
Comment allons-nous faire pour
Hello, this is Saliu talking.
Yes.
Okay.
Yes.
Do you hear me?
Yes, I can hear you. What do you want to say?
Okay.
Yes, please, excuse me, I want one more question, please. I have one more, the last question.
Okay. Well, I think that it's getting a bit difficult with the sound quality and everything. So I think we will conclude the formal part of this webinar now. But we will stay behind, and we can take any other questions. If you will stay behind, those that have more questions, please stay behind, and we will talk to you. There are over 100 people in this webinar, and we cannot keep everybody here. For that, those that are interested can stay behind. So, but I have one more thing that I just wanted to mention. There was another question actually on the continuity of suppliers and the reliability of suppliers, and that if you engage with a supplier, then you might get into trouble if they go out of business or decide not to do remote monitoring equipment anymore. And I just wanted to mention that many IALA industrial members are providing solutions, and some of them have been mentioned, I think, and they are, of course, IALA members are very reliable and provide excellent products. But there is a webinar which I am aware of, which is happening. I thought actually that if I share my screen, I thought actually that Simon was retired, but he is now seems to be full-time engaged in talking to the world about monitoring and asset management of AtoN navigation. So this is one of the IALA industrial members who is planning another webinar in a week's time. Note the timing is different. It's 9 p.m. 9 in the evening. But this is
Omar, that time is incorrect.
Oh, I just received this on an email. Anyway,
Yeah,
those that might want to follow that can Google it and perhaps find it. So, Geraldine, I think you have some final words to close this this webinar.
Yes, thank you, Omar. This brings us to the official end of the webinar. Many thanks to all of you for joining us, and special thanks to our excellent speakers. Please note that the next webinar will take place on Thursday, 28th January at 1600 UTC, and we will travel to the Caribbean. The subject is on buoy moorings. It's one of the cases is the results of recent buoy mooring trials in Belize waters. So I hopefully see you there again. Please feel free to stay and chat with us informally after the official end of the webinar, which is actually now. Thank you very much. See you later.
Okay, so